Hey guys, this is Professor Janacek. I want to go over an application where we determine the length of a curve. Let us find the length of the curve f of x, described by 2e to the x plus 1 over 8e to the x on the interval from 0 to the natural log of 2. So to begin with, we have our function f of x is 2e to the x plus 1 over 8e to the x. Now, we're looking at this in terms of x's, so we'll use this first formula. And I notice in that formula, I'm going to need f prime of x squared. So let's start with that. Okay, so I need to determine f prime. You know what? I'm not real crazy about taking the derivative when I have an e to the x in the denominator. Much more comfortable when it's not in the denominator. So let's rewrite this as 2e to the x plus 1/8 e to the negative x. Now I can take the derivative of that. That's 2e to the x minus 1/8 e to the negative x. Notice we use the chain rule there. Next thing we want to do is square this. So that's going to be 2e to the x minus 1/8 e to the negative x quantity squared. Now you might need to take your time with this. If you need to write this out twice and multiply, that is fine. Again, take your time with this. You should end up with 4e to the 2x minus 1/2 plus 1/64 e to the negative 2x. Again, take your time with it. If you need to go through and multiply all this out, do so. Combine like terms, and you should end up with this bit here at the back. Okay, so I think we have everything. We're ready to use our formula. L is the integral from a to b. Our interval goes from 0 to the natural log of 2 of the square root of 1 plus our f prime of x squared. So that's the 4e to the 2x minus 1/2 plus 1/64 e to the negative 2x. All that's under the radical, and then of course we're integrating with respect to x there. Okay, well let's see. Let's start simply. I can combine the 1 and the 1/2, so that gives us 4e to the 2x plus 1/2 plus 1/64 e to the negative 2x dx. All right, now let's see, what can we do with this? Well, I do recognize that this looks a lot like that. In fact, those two things are identical except for the negative. The f prime squared has a negative, whereas what I have now is a positive. All right, well, that's not so bad. That just means that since this came from that, I can rewrite this. Only difference will be that negative. So turns out you're going to love this. Ooh, and by the way, I put a 12 there. That's not a 12. That's a 2. Check this out. Inside here, we end up with 2e to the x plus 1/8 e to the negative x quantity squared. Isn't that lovely? Again, I'm just using the connection that I see between those two, and I'm changing that sign. I had a negative here, which came from that negative here. In this case, though, I have a positive, so it's the same thing, only with a positive. We'll actually get to use this. This happens quite regularly. But this is even better. Check this out. We have the square root of something squared. Ah, well, those two kind of undo one another. So we can get rid of that radical. Isn't that nice? Now I think we're about ready to integrate. Integrating 2e to the x gives us, well, 2e to the x. Integrating 1/8 e to the negative x, remember I would actually need to use a little bit of a u substitution on this, and we get negative 1/8 e to the negative x. Just be careful with that. We're evaluating this from 0 to the natural log, darn it, from 0 to the natural log of 2. Now, I'm not real crazy about evaluating negative exponents, so I'm going to go ahead and rewrite this as 2e to the x minus 1/8. Sorry, no. What I want to do is write that as 1 over 8e to the x. So now I don't have a negative exponent. Makes it a little easier to evaluate. And so let's see, that gives us 2e to the natural log of 12. Oh, that's natural log, not 12. That's a 2. Why do I keep writing 12? Grr. Okay. 2e to the natural log of 2, that's going to be nice, minus 1 over 8e to the natural log of 2, minus 2e to the 0, minus 1 over 8e to the 0. Well, e to the natural log of 2, that's just a 2. I'll distribute this negative out as well, so I have minus, let's see, 2e to the 0, that's just 2 times 1. Again, distributing that negative, I get a plus here in the back, 1 over 8 times 1. And from here on out, it's just a little bit of arithmetic. I'll let you work through that. You should end up with 33 over 16. Hope that makes sense. Enjoy!